Today's lesson is on classifying triangles. When we get finished with this lesson, we should be able to interpret measurements and symbols in drawings of triangles, list and describe the 3 ways to classify a triangle by sides, list and describe the 4 ways to classify a triangle by angles. And our overall learning target is, when given a drawing of a triangle or information about its measures, to classify the triangle by both sides and angles. We're going to start off by talking about what is a triangle. So a triangle is simply a 3-sided polygon. So it's simply a shape that has 3 straight sides. It's a closed shape. So on this graphic organizer, which I'd like for you to use when you're doing your assignments for this lesson, we've kind of got 2 different columns. The left side, we're going to be talking about classifying triangles by sides. On the right side over here, we're going to be focusing on classifying triangles by angles. So we're going to start with sides. The first way that we can classify triangles by their side lengths is called scalene. And in a scalene triangle, sorry about that. In a scalene triangle, all 3 side lengths are different. None of them are the same. So we can say no sides are the same length. They all have to be different. So you could have a triangle like this one where this side is 3, this side is 7, and this side is 5. All 3 are different. An isosceles triangle, the second way to classify by sides, has at least 2 sides the same. So we could have something like this. We could have a triangle that has these 2 sides being 6 and this bottom base being 4. So 2 of the sides are the same, 1 is different. And I didn't mention before, but when you're looking at measurements of a triangle in a drawing, the side lengths are going to be written on the outside of the triangle, kind of in the middle of the side that length represents. So this side right here, the length of it is 6. The third kind of triangle, or the third kind of way that we can classify triangles by side lengths, is called equilateral. Equa means equal, lateral means sides, and in an equilateral triangle, all 3 sides are the same length. Okay, so all 3 sides have to be exactly the same length. So we could have a 2, a 2, and a 2. All 3 sides are 2. Now sometimes they don't give us the measurement in a number. Sometimes we're given symbols in geometry. So we have to learn how to interpret these symbols. So in a triangle, any sides that have the same length as each other have what's called a congruence mark through that side. So as you can see in this last example, we have 3 red congruence marks through all 3 of the sides because all 3 of those are the same length. Back up here in our isosceles example, we would have had marks just through those two sides. Because remember, this was 6, this was 6, and this was 4. So this side that was 4 would not have one of those marks through it. So sometimes, even though you don't know what the measurement of a side is, you don't know how long it is, you still can know that it's scalene or equilateral or isosceles because of these congruence marks. Now let's look at how to classify triangles according to their angles. Now, earlier in the week, we learned how to classify angles. And we're going to use that information to help us to classify triangles. Triangles have 3 angles, 3 interior angles in them. So in this example right here, there's an angle, and there's the third angle. Okay, so those are the 3 angles that we're talking about. And if you were going to classify a triangle as being acute, all 3 angles are less than 90 degrees because acute means less than 90. So in an acute triangle, all 3 of the angles have to be less than 90 degrees. So for example, this could be 75 degrees, 60 degrees, and 55 degrees. All 3 are less than 90, so that would be classified as an acute triangle. Now you'll remember that an obtuse angle is an angle that is greater than 90 and less than 180. So an obtuse triangle has one angle that is between, well, we'll just say that is greater than 90. Okay, so only one of the angles is going to be bigger than 90 in an obtuse triangle. So clearly, in this example, this is the biggest angle. It has the, the 2 sides are spread the furthest apart, okay? And the other 2 angles are smaller. And this could have something like, this could be 120 degrees, 30 degrees, and 30 degrees, okay? One of the angles is more than 90, therefore it's an obtuse triangle. Okay, in a right triangle, exactly one angle is 90 degrees, okay? So one of the 3 angles is going to be 90. And remember, the symbol for a 90 degree or right angle is this kind of box that's at the vertex of the right angle. So in this case, this triangle could be, 90 degrees there. That has to be a 90. 50 here and 40 degrees up here. Now, there's one other kind that is not on this graphic organizer that I just want to talk about for a minute. And it's called equiangular. And I'm just going to draw it in some space over here. So it's called equiangular. Equal angles, okay? So an equiangular triangle is going to look something like this. All the sides are going to be the same length, and all of the angles are going to be exactly 60 degrees. Okay, all 3 have to be 60. Another way that we could represent an equiangular triangle would be to use symbols to represent the congruent angles. And with lengths, remember, we had like a congruence mark through the side. With angles, we used an arc, kind of a little rounded symbol in each angle. So, for example, this triangle, if we put these little arcs in each angle there, that would be telling us that every angle in that diagram that has an arc they're all the same measure as each other. So there's 3 arcs in this drawing, 3 red arcs. That means all 3 of those angles are the same. So that would make it equiangular. So there are actually 4 ways to classify by angles. Now, equiangular triangles could also be classified as acute, because if you have 60 degrees, 60 degrees, and 60 degrees, those clearly are all 3 less than 90. So it's also acute, but a more precise way to classify it is to say that it's equiangular. This next statement on here, the sum of the measures in the 3 angles of any triangle is 180 degrees. We're going to talk more about that after we get back from Christmas break. I'm going to spend just a minute answering these last 2 questions on here, or drawing these last 2 examples. So they're asking us to come up with a drawing that fits both of these ways to classify. So on this first example, they're asking us to make a triangle that has all 3 sides different, okay, because in a scalene, none of the sides can be the same length. And one of the angles has to be greater than 90. That makes it obtuse. So I'm going to start by making sure that I have a great big angle. Okay. And just connect and make my triangle. And I'm going to say this is 130 degrees. This is 11. This is 9. And this is 5. Okay, so that would fit the definition of being both obtuse and scalene. On this next one, isosceles right, we're looking at a triangle that has one 90-degree angle and 2 sides are the same length. So I'm going to draw myself a right angle there, put my box. And we know 2 sides have to be the same length, so I'm going to draw congruence marks through 2 of my sides. So that would be showing that 2 sides are the same length, so that would be an isosceles right triangle. All right, so let's look at some more examples so that you guys can have some solid information to do your assignment. Okay, so here are some questions we're going to work through together. This says classify the triangle by sides. So first of all, you have to clue into what the question's asking me. It's wanting to know about sides. Our options for sides are scalene, isosceles, and equilateral. Okay, so no sides the same, 2 sides the same, 3 sides the same. So look at A here. We have this side length is 10, this one is 8, this one's 13. All 3 different numbers. Therefore, A is scalene. Now if we look at B, 7, 7, 7. All 3 are the same. Therefore, it's equilateral. Example C, we've got 15, 15, 6. 2 sides are the same. Therefore, that makes it isosceles. So that's how you're approaching these problems. When you're classifying by sides, you're looking at the side lengths and deciding if it's no sides the same, 2 sides the same, or 3 sides the same. And then you pick the correct classification that goes along with that. Okay, so here's some more examples. Classify by sides. We've got a 5 and a 5 and a 6. So that's going to be isosceles. 2 are the same, 1 is different. Number 2, we have 19, 19, 19. All three sides are the same. That's going to be equilateral. Number 3, we have a 6, an 8, and a 10. Those are our side lengths. All three are different. That means they're scalene. Number 4, we got numbers and symbols going on in this one. Okay, so let's classify first by sides. That's what we're doing in this example. We're just doing sides. We don't have any side lengths on this drawing. We have angle measurements inside the drawing, but we can't use angle measurements to classify by sides. We have to use side measurements. Well, there aren't any numbers written out here, like there were on the other problems. But what we do have, we have symbols to help us. And we have 2 congruence marks. We have this one through one of the sides and this one through one of the sides. So we have 2 sides that have congruence marks. That means that this side and this side are the same as each other. They're equal. So we have 2 sides the same. So that's going to be isosceles. Okay, now let's look at classifying by angles. So in the directions, it clearly says to classify by angles. So we have to make sure we're using the correct terms for that. So we had acute, obtuse, right, and equiangular. Okay, these were the 4 ways to classify by sides. And remember, let's see, these were on the right side of our graphic organizer, okay, by angles. We're working by angles right now. Okay, so let's look at example A. We don't have any measurements given to us. So we're going to have to try to look at the symbols that they give us to figure out and interpret what they're telling us. We have a box in this corner. We know that this box is the symbol for a right angle. So we know that this is a 90-degree angle. And we know when a triangle has one 90-degree angle, we can classify it as a right triangle. Okay, looking at B, we've got 60 degrees, 60 degrees, and 60 degrees. It's true that we could say that this is acute because all 3 angles are less than 90, but a better, more precise way to classify it would be to say it's equiangular because not only are they all less than 90, but they're all exactly the same. All the angles are equal to each other. And then looking at example C, we've got a 60-degree angle, an 85-degree angle, and a 35-degree angle. All 3 of those measurements are less than 90, so that means that this is an acute triangle. Okay, that answer is right here. Okay, so you're looking at the measurements of the angles and looking at the definitions of the 4 ways to classify by angles and choosing the correct one. All right, let's try some of these. So this says classify by angles. All right, so I think that should have been number 1. Again, this problem has no measurements on the inside of it. But we do have these symbols, which are congruence arcs. There's a congruence arc in all 3 of the angles. So that's telling us that all 3 of those angles are congruent to each other. So this is going to be equiangular. Okay. Number 2 over here, my second number 2. We've got a 120-degree angle, a 40-degree angle, and a 20-degree angle. Well, we have one angle that is greater than 90, this one. So that fits the description of being an obtuse triangle. An obtuse triangle is a triangle that has one angle greater than 90. Okay, now number 3, we've got 78 degrees, 80 degrees, and 22 degrees. Well, they're not all the same, clearly, so we can't pick equiangular. We don't have a right angle, so we can rule out right angle. So we have to decide, is this acute or obtuse? And we know from the last problem we did, an obtuse triangle has to have one angle greater than 90. We don't have that. So we can rule out obtuse. So we're left with acute, but let's make sure that's correct. Acute triangles, all 3 angles have to be less than 90. And yes, they are all 3 less than 90. So this is acute. And in number 4 here, we've got a box in this angle right here. That's a symbol for a right angle. So it's telling us that this is a right triangle. Okay, that's just the same as if it said 90 degrees. That's what that box means.